Good day, I'm Dr. T and welcome to my office. So today I'm working a few chemistry problems, and this one I'm diving into is a stoichiometry problem involving a gas. So in this case, what mass of calcium carbonate would be generated from 250.0 milliliters of carbon dioxide gas being dissolved in excess calcium hydroxide solution? I think I need the word A there. Anyways, assuming the pressure is 1.01 atmospheres and the temperature is 22.5 degrees Celsius. Okay, so there's a very good chance this is a bit of an equilibrium reaction, but the fact that the calcium hydroxide is in excess and that's not being talked about, we're going to assume this is a one-way reaction. So let's look at our players. Calcium carbonate, I know that calcium has a charge of 2, so does carbonate. So calcium is plus 2, carbonate is minus 2. So that's going to be CaCO3. Calcium hydroxide, CaOH2, plus 2, minus 1. Okay. And for this, I'm going to need a periodic table, so BRB. And I'm back. Okay, so I've got my periodic table off screen. And for this guy, I don't really care about his formula weight. It's an excess. Now, I also have another player that I forgot to write in that's carbon dioxide. That's this guy. Once again, I don't care about his formula weight because he's coming in as a gas, so I'm not going to be using counting by weight. But this guy is going to be a nice solid. And the loud car is gone, hopefully. This guy is going to be a nice solid. And as such, I'm going to be looking at it in terms of weight. And in fact, actually, that's the entire question. What mass? So for this guy, I'm going to need a formula weight. So formula weight, CaCO3. Okay, so for this one, I'm going to need the weight of the calcium, which I get as 40.08, plus the weight of the carbon, which should be 12.01, I think. Yep. And all the units, by the way, are in Daltons, or grams per mole, which are effectively the same thing. Okay. Plus, let's see, oxygen should be 16.00. Yep. Times 3. Because there's 3 of them. Okay, so I take 40.08 plus 12.01 plus 16 times 3. By the way, make sure you use your calculator. Sometimes you can just type this in and the calculator will handle it. The TI-83 pluses will. Other calculators won't, and they'll just do them in order, not order of operations. So in this case, I find the mass is 100.09, and I'm going to put units of grams per mole. Once again, it's equivalent to Daltons. Okay, so for this guy, actually what I do need to know is the gas constant. And depending on how things are going, on a test, I typically give those. On other activities, those might very well be on a useful information sheet. So, was I so nice to do that? Yeah. So this is my lab book. Obviously, it's a mess. So in this case, R is going to equal 0.082057 liters ATM mole Kelvin. Okay, so now I have my R. I actually do want to make one quick check on my R. There are different R's depending on what units you have. So you want to make sure that all of your units match. So I have over here ATMs. I have ATMs over here. So that's good. That's in milliliters, that's in liters. So I'm going to have to convert one or the other. I usually like to convert the thing that has the least number of units to it. Okay, so let's plug this into ideal gas law, and that will give me moles. And then for moles, I can get this guy. I'm going to need a chemical equation here shortly too, but we'll cross that bridge when we come to it. Okay, so PV equals nRT. That's my ideal gas law. I know that my pressure is 1.01 atm. My volume, once again, I have to match, so I'm going to say this is 0.2500 liters equals moles. I want to know what that is, times 0.082057 liters ATM moles Kelvin, and times, that's in degrees Celsius, but I have to convert that into Kelvin, otherwise things do not end well. Okay, so now I just have to simplify and solve for that question mark. So calculating time. So 1.01 times 0.25 gives me 0.2525, and this is going to be ATM liters, equals question mark times 0.082057 times parentheses, because I have to do not what the normal order of operation would be. So I have to bring in the parentheses to force the order of operations to be slightly different. To 2.5, and of course that's going to be in Kelvin, plus 273.15, close the parentheses. And now I get times 24.26, let's see, what do I have here? Liters ATM moles, because, no, that didn't cancel, but that canceled with that. Okay, so now I'm going to take this side and divide it by the other, so 24.26 liters ATM moles divided by 20. Quick point, always want to double check your work, just make sure you didn't put the wrong number. This is also why you always want to show your work. If I catch that you made a mistake and I see that you just transposed the wrong word or the wrong number, minor points removed. Because you know what you're doing, you just made a silly mistake. So I have to take something off, but it's not going to be much. Okay, liter ATMs cancel. This whole thing cancels. Moles flop to the top. So now I'm going to do 0.2525. I don't want to do that. Times second answer equals 6.12569 moles. I know that's way too many sig figs, and that's the way I like it, because I'm going to round at the end. That equals question mark. Okay, so now what I need to do is do some stoichiometry. So I'm going to start with this. So I know that would be moles of CO2. So I know I have 6.12569 moles CO2. And at this point, I need to do mole-to-mole ratio, but to do that, I need a balanced chemical equation. So I'm going to carve out some space over here. And I'm going to say, okay, CO2 plus CaOH2 yields CaCO3, and I'm guessing I'm going to get some water off of this in the process. Because, yeah, those hydrogens got to go somewhere. Okay, so let's see. Let's try some balancing. Hydrogens balance. Oxygens balance. Yeah, this is actually looking pretty good. So this is already balanced. I can tell that because I've got 1, 2 hydrogens, there's 2. I've got 1, 2, 3 oxygens, there's 3 oxygen there. 1 carbon, yeah, and calcium. Yeah, okay, so this is 1 to 1. Okay, so this is 1 mole CO2 and 1 mole CaCO3. Wow, that was nice. 1 to 1's always fun. Okay, and then afterwards, I'm going to bring in that formula weight that I worked up earlier. So I'll say, okay, that is 100.09 grams CaCO3 for every 1 mole CaCO3. And then I'm going to type this in the calculator. Obviously, I'm not actually going to type that in the calculator because, you know, it's 1 to 1. So I'm going to times that by 100.09. That gives me 613.12 grams. Now I have to go for some sig figs. Okay, that's 5 sig figs. This guy, how many sig figs is that? That's looking like 3 sig figs, frankly. That's going to be like 4 sig figs there. That's a lot of sig figs. That's 4. That's 3. So this is 3 sig figs. So that's really there. That's exact. That's the, whatever, 5 sig figs there. That doesn't count. So this is 3 sig figs. So it rounds to there. So my answer is 613 grams CaCO3. Yay! I have my answer. So with that said, hey, have fun with some stoichiometry, and I'll see you in later videos.